Vicky Cusack on Mornings on ABC Radio across the Kimberley, Pilbara and Gascoyne.
Good morning, that's right. It's me, Mickey, with you, coming to you across the Kimberley, Pilbara and Gascoyne. And I am coming to you from Broome, Yalwaru land. Now, stromatolites might look like rocks, but you know that they're living relics of ancient systems that thrived on Earth billions of years ago. And scientists may have just glimpsed the very moment that sparked the life on Earth. The researchers witnessed this chemical reaction, and they're going to explain how simple molecules combined can form life's building blocks. Brendan Paul Burns is an associate professor from the School of Biotech and Biomolecular Science at Sydney Uni. He joins me now. Brendan, good morning.
Good morning.
Let's start. Can you start? I've seen you mentioned it said the Asgard archaea. Can you explain what that actually is to me?
Yeah, sure. So, the archaea themselves are a type of microorganism that are similar to bacteria, which probably most people know about, but they're quite evolutionary distant, and they're found in a lot of what we call extreme environments. But the Asgard archaea are a relatively new, newly discovered group of organisms about 10 years ago or so. But what is really cool is that they've been shown to be really similar with their makeup, their genetic makeup, to eukaryotic cells. And eukaryotic cells are the cells that make up all complex life, plants, animals, us. So this Asgard archaea are likely key in that kind of junction between becoming a simple microbe to eventually becoming us.
I liked how you said plants, animals, us. That was very well said. Can you tell me a bit about what you observed with all these things?
Yeah, so basically we went digging literally into the microbial mats and stromatolites over in Shark Bay, and these are amazing systems. They're actually teeming with microbial life, and we managed to discover some of these really weird group of organisms, these Asgard archaea, amongst others, hanging out in these mats. And what we did was not just looking at what their DNA, which makes up every cell and tells us what they do, but we also managed to visualize them, and for the first time visualize them interacting with another bacteria. And that is really important because some of the models of how complex cells actually came about was the interaction of an Asgard archaea with another bacteria. They kind of the Asgard swallowed the bacteria, as a very simple way of putting it, but we actually managed to visualize this direct interaction for the first time in modern systems.
And is that why you're calling that chemical reaction first contact?
Exactly. So it's this idea that first time we've actually seen these two families of organisms. I guess the analogy that I like to use is one of, say, Romeo and Juliet, two very distant families that have decided to come together instead of hanging apart. And we may be in a modern analogue in these Shark Bay mats, seeing it actually almost like a mirror happening all over again.
I love that. That's a perfect way to describe it for us people, because when you're saying microbiome and whatnot, I keep on thinking about gut health, because obviously that's a big trendy word with people's gut health and what's happening. Is there any correlation between the two?
No, not necessarily direct correlation, but I guess you're right in that whenever you think about microorganisms and bacteria, we often associate them with, often what we associate them is with bad things, with infections, and it's true that there are a lot of nasty organisms out there. There's also many beneficial ones that hang out in our gut, and microbes everywhere on Earth basically help, I guess, drive all of the cycles that keep all life ticking over. So this is my little bit of a plug for microorganisms. So even though what we're doing isn't necessarily directly related to, say, the gut microbiome, what we're trying to understand is how we, humans and complex life, first came about way back on an early Earth, a couple of billion years ago.
And take me back to when you said before that you were digging. Can you paint me a picture of you being there on the day, how you're digging amongst the rocks to find these things?
Well, okay, so what we do is going out to Shark Bay, and you're literally wading around. And again, another really cool analogy I have is it's like going back through time. When you're out there, you're kind of wading through these. And we're basically taking small samples of these mats and rock-like stromatolites, and we take them back to the lab, and that's when we start doing all the cool techniques where we extract molecules like DNA, and we grow them up and we put them under the microscope and we visualize them. So most of the actual work we do is back in the lab and on a computer actually. But in the field, we actually take them from their home to have a look at them, if that makes sense.
What do you prefer, the field work or the lab work?
Well, it's awesome getting out in the field. I just don't, unfortunately, get the chance to as much. Shark Bay is an amazing area. It's absolutely beautiful. So I'd love to get out there more, just with time and other things that I tend to find myself behind a computer or in the lab nowadays.
And then when you're in the lab and you first got this chemical reaction, you coined it first contact, was there a big celebration? How does everybody relate to each other when that happens?
Yeah, I mean, I think I'm trying to remember exactly. It was a colleague of mine who actually visualized this on the microscope, was sending us messages one night from memory. And your immediate reaction is, wow, look what we've seen. And then you also have to kind of temper it to make sure you can kind of follow that up and evaluate exactly what's happening. But the initial reaction is a little bit of a eureka moment. You think, wow, look what we may have found in terms of helping us understand how life got about. So it's really cool.
Oh, that is really cool. All right, before I let you leave, how can this discovery help us understand life beyond?
Beyond, as in beyond
Earth, yeah.
Pale blue dot.
Yeah.
Look, it's always a long bow, but understanding how complex life on Earth evolved helps us understand the potential for life elsewhere. I personally think, and I think a lot of people, if we're going to find life elsewhere, it could be very simple, could be microorganisms like we see on Earth. So if we can understand the processes of how microbes evolved, how they became more complex, it may help us when we look for things like biosignatures, that if they may be on another planet, for example, or maybe hanging out beneath the surface of Mars if we're lucky.
Very cool. Thank you so much for your time this morning.
No problem. Thanks for having me on the show.
That was Brendan Paul Burns. He's an associate professor and he's been working on that project. Alongside him was Kymberley Oakley. She's an Indigenous language expert in Indigenous knowledge. She's going to start now with a welcome to country.
I'd like to acknowledge that I am sitting on Gadigal land, and I also would like to pay my respects to their elders past, present and emerging. I also want to pay my respects to my mob, the Malgana mob in Shark Bay, Western Australia, and I would like to acknowledge wherever you are sitting and listening to this at the moment.
That was beautiful, and I am on Yaru land at the moment, and I feel very happy to be here. Now, Kymberley, we heard the Norse name Asgard, archaea there earlier, but there's an Indigenous name used. What can you tell me about that?
Yeah, so there's two parts to the name. So the first bit is actually Latin, and I may actually pronounce this incorrectly, and then the second part is actually Malgana. So I'll give it a go. The Latin, nano K-eum, and then it's Maru Maya.
And what does that mean?
Yeah, so the first bit you're going to have to ask Brendan about the first naming of it, but the second bit actually means ancient home.
And when you say that it means ancient home, is that a reference to the living rocks?
So it's more about where the mats actually live in terms of their home.
Why is it so important to include Indigenous names in this language and for this story?
So for Aboriginal and Torres Strait Islander people, land and waters are often referred to as country, living in interconnected systems. So for these mats, they're complex communities for microorganisms and a part of these ecosystems. Using an Indigenous name acknowledges that these place and life forms exist within country, and that it's better known and cared for and understood for tens of years.
That was Kymberley Oakley, an Indigenous language expert, and that's a little bit of science for you this morning. Time to get